Hello students, welcome to the study of unit number 3. It's a classification of elements and periodicity in properties. This is the fourth episode of our study about periodic table. Today we will learn one important concept of this periodic table. You know, the 118 elements present in the modern periodic table is classified into 4 blocks. The periodic table, the elements of the periodic table are broadly classified into how many blocks? 4 blocks. Okay, that classification we will discuss in today's class. You know, what is the basis of classification of elements into 4 blocks? ಗೊತ್ತಿರೋ ಎಲಿಮೆಂಟ್ನ 4 ಬ್ಲಾಕ್ಗಳಾಗಿ ವಿಂಗಡಣೆ ಮಾಡಿದ್ದಾರೆ. ಯಾವ ಆಧಾರದ ಮೇಲೆ ಮಾಡಿದ್ದಾರೆ? ವಾಟ್ ಈಸ್ ದ ಬೇಸಿಸ್ ಆಫ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್? The classification is done based upon filling up of entry of electrons. Which electrons? Valence electrons. So when you write the electronic configuration of a atom of an element, if the valence electron enters into which orbital, based on that the classification is done into 4 blocks. Okay, so ಯಾವ ಆಧಾರದ ಮೇಲೆ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ? So the classification is done based on filling up or entry of valence electrons. Valence electron, we call it as a outermost electron, we call it as a last electron, even we call those electrons as differentiating electrons. Okay, so filling up of valence electrons into different orbitals. If the valence electron, last electron, outermost electron, if it enters into s orbital, s block. If it enters into p orbital, d orbital. So based upon that parameter, adharada mele the elements are classified into how many blocks? 4 blocks. Okay, so we'll study very what you call the salient features of this classification in today's class. Clear? Okay, fine. The first classification is elements are classified into S block. In the periodic table, the group number 1 and 2, that's the elements hydrogen, lithium, sodium, potassium, rubidium, cesium and francium belong to group number 1, and beryllium, magnesium, calcium, strontium, barium and radium belongs to group number 2. So the 2 groups belongs to which block? S block. Okay, so we'll learn how these elements are classified as S block. We'll see later. The second block of the periodic table is P block. Total 6 groups. That's group number 13, 14, 15, 16, 17 and 18. Total 6 groups, 13 to 18 belongs to P block of the P block. The third classification is the elements are classified into D block. Total the 10 groups, that's a group number 3 to 12. So 3, 4, 5, 6 up to 12. Total the 10 groups 3 to 12 are classified under the block D block. Whereas the last classification is F block elements. The 2 rows which are kept below the main body of the periodic table, they were called as lanthanoids and actinoids. Lanthanoids and actinoids, these 2 rows. So lanthanoids composed of 14 elements and actinoids composed of 14 elements. These total 28 elements which are kept below the main body of the periodic table, they comprises of, or they are called as what? F block elements. Okay, ಹಾಗಾದ್ರೆ ಈ ನಮ್ಮ ಆವರ್ತ ಕೋಷ್ಟಕದಲ್ಲಿ ಎಷ್ಟು ಬ್ಲಾಕ್ಸ್ ಇದಾವೆ? 4 ಬ್ಲಾಕ್ ಇದಾವೆ. ಯಾವ ಆಧಾರದ ಮೇಲೆ ಈ ವಿಂಗಡಣೆ ಮಾಡಿದ್ದಾರೆ? ಸೊ ಯಾವ ಆಧಾರದ ಮೇಲೆ? ಎಂಟ್ರಿ ಆಫ್ ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಕೊನೆಯ ಎಲೆಕ್ಟ್ರಾನ್, ಎಲೆಕ್ಟ್ರಾನಿಕ್ ವಿನ್ಯಾಸ ಬರೆದಾಗ ಕೊನೆಯ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಕಕ್ಷಕಕ್ಕೆ, ಯಾವ ಆರ್ಬಿಟಲ್ಗೆ ಹೋಗ್ತದೆ, ಅದರ ಆಧಾರದ ಮೇಲೆ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ಫೀಚರ್ಸ್ ಅಷ್ಟೇ ನಾವು ಸ್ಟಡಿ ಮಾಡೋಣ. ಬಿಕಾಸ್ we have a separate chapter called as S block, P block in PUC first year. In PUC second year, P block, D block, F block. So detail ಆಗಿ ಸಪ್ರೇಟ್ ಚಾಪ್ಟರ್ಸ್ ಇದಾವೆ, ಅಲ್ಲಿ ಆ ಎಲಿಮೆಂಟ್ಸ್ ಬಗ್ಗೆ we will study in detail. So in today's class, we'll have a brief introduction of about this classification. Clear? Okay. Fine. The first block is S block elements. What are S block elements then? The elements in which differentiating electron andreno valence electron, or we call it as a outermost electron, even we can call it as a last electron. Okay, so the elements in which the valence electron enters into s orbital, they were called as what? S block elements. Hagadre, when you write the electronic configuration, okay, electron vinyasa anteve. In Kannada, electronic configuration is called electron vinyasa. So when you write the electronic configuration, if the valence electron, last electron, differentiating electron, or outermost electron, if it enters into s orbital, those all elements were called as what? S block elements. Hagadre, in the periodic table, group number 1 and 2, only two groups belong to this block. Why? Because you know, s orbital can accommodate only 2 electron, maximum of 2 electron. S orbital can accommodate 1 electron or 2 electron, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ accommodate ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. Since the s orbital can accommodate 2 electrons, we have two groups. That's a group number 1 and group number 2 belongs to S block. So can you see here? So these two groups 1 and 2. Okay, so why group number 1 and 2 are called as S block elements? We'll see their electronic configuration. Electronic configuration ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ ನಿಮಗೆ. This is the electronic configuration of group number 1 elements except hydrogen. Hydrogen ಒಂದನ್ನ ಬಿಟ್ಟು. Why hydrogen is an exceptional case here? We'll see at the end of the today's class. ಅದ್ರ ಬಗ್ಗೆ ಆಮೇಲೆ ಹೇಳ್ತೇನೆ. ಹೈಡ್ರೋಜನ್ ಒಂದನ್ನ ಬಿಡ್ರಿ. Lithium, its electronic configuration is 1s2 2s1. Here total 3 electrons are there. 2 electrons are in a 1s orbital and 1 electron in a 2s orbital. So this 1 electron, this 1 electron is what? It's a valence electron. It's a last electron. It's outermost electron. Enters into which orbital here? 2s, s orbital hogide. Therefore lithium belongs to S block element. If you take a sodium, atomic number 11, its electronic configuration is 1s2, 2s2, 2p6 and 3s1. So this comprises of 3 shells. This is first shell and these two belongs to second shell and this is the third shell. Valence shell anta irtave. The electron present in a valence shell is valence electron. So this 1 electron, can you see that pointer, red color pointer? This 1 electron is the last electron. Enters into which orbital? S orbital ge hogide houdillo. Therefore sodium belongs to which block? S block. In the same way, if you take potassium, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Last electron enters into s orbital. Take rubidium as an example. Last electron enters into 5s orbital. Cesium, last electron enters into 6s orbital, and francium, last electron enters into 7s orbital. Hagadre, these group number 1 elements can be called as what? This is where S block elements, isn't it? In the same way, group number 2, beryllium, magnesium, calcium, strontium, barium and radium. ಈಗ ನೋಡಿ, beryllium electronic configuration 1s2 2s2. Outermost electrons are, these are the 2 electrons, enters into s orbital. In magnesium, outermost electronic configuration dalli ಏನಿದೆ 3s2. The valence electron enters into s orbital. Calcium dalli, strontium dalli, barium, radium. So you take any element of the group number 2, the 2 valence electron enters into s orbital. Clear? So now I think you got an idea why these group number 1 and group number 2 elements were called as S block elements. ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ, ಸೊ ಇನ್ ಗ್ರೂಪ್ ನಂಬರ್ 1 ಏನಿದೆ ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಶೆಲ್ ನೋಡಿ 2s1 3s1 4s1 5s1. ಸೊ ಇನ್ ಜನರಲ್ ಕ್ಯಾನ್ ವಿ ರೈಟ್ ಎಸ್ ns1 ಬರಿಬಹುದಾ? ಎಸ್. ಇಲ್ಲಿ ನೋಡಿ ಜನರಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನಂತ ಇದೆ, ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ 2s2 3s2 4s2 5s2 ಆ್ಯಂಡ್ ಸೊ ಆನ್. ಜನರಲ್ ಆಗಿ ನಾವು ಕ್ಯಾನ್ ವಿ ರೈಟ್ ns2. Here general outer electronic configuration ns1, here ns2, isn't it? So ಹಾಗಾದರೆ ಎರಡು collectively ಏನು ಅನ್ಬೋದು? This point is important which can be asked for 1 mark in the examination. The general outermost electronic configuration of S block element is what? ns1 to 2, because in group number 1 it is ns1 and in group number 2 it is ns2. ಎರಡು ಸೇರಿಸಿದ್ರೆ ಏನಂತ ಬರಿಬೋದು? ns2. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 1 ಮಾರ್ಕ್. ಓಕೆ, ಎಕ್ಸಾಮ್ದಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಫೈನ್. And the elements of group number 1, they were called as alkali metal except hydrogen. Lithium, sodium, potassium, rubidium, cesium and francium were called alkali metals, whereas group number 2 elements are called alkaline earth metals, belongs to S block. And these S block element, these all are metals. They are very reactive metals. They have the tendency to lose outermost electron easily, readily, forming +1 ion in case of alkali metals and +2 ion in case of alkaline earth metals. Okay, and because of this reactivity, they were never found in a pure state. They are never found in a pure state. Okay, so here alkali metal, alkaline earth metal, about this, then reactive metals, they show positive charge, +1 and positive charge, hence they were called as electropositive. Why they are more reactive, everything I will tell you in the offline class. When you come to the college, I'll explain these points in detail. ಓಕೆ, ಸೊ ಈಗ ಇದ್ರ ಬಗ್ಗೆ ವರಿ ಮಾಡಬೇಡ್ರಿ, ಇದ್ರ ಬಗ್ಗೆ ನಾನು ಇನ್ನೊಂದು ಸರಿ ಹೇಳ್ತೇನೆ, ಕ್ಲಾಸಲ್ಲಿ ಹೇಳ್ತೇನೆ ಕಾಲೇಜಿಗೆ ಬಂದ ಮೇಲೆ ಯಾವ ಪಾಯಿಂಟ್ಸ್ನ. ವೈ ಗ್ರೂಪ್ ನಂಬರ್ 1 ಆರ್ ಕಾಲ್ಡ್ ಅಲ್ಕಲಿ ಮೆಟಲ್ಸ್, ಗ್ರೂಪ್ ನಂಬರ್ 2 ಆರ್ ಕಾಲ್ಡ್ ಅಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್, ಅದರದ್ದು ಮೀನಿಂಗ್ ಏನು ಹೇಳ್ತೇನೆ, why they are reactive, how they are reactive, how they form +1 ion and how they form +2 ion. About these points I'll tell you in the college. Clear? ಅದ್ರ ಬಗ್ಗೆ ಈಗ ವರಿ ಮಾಡಬೇಡ್ರಿ. Fine. Next block is P block elements. Okay, you get the periodic table. It can be called as a flow, ಏನನ್ಬೋದು, ray diagram of a periodic table. Okay, so this part it belongs to what? P block elements. Total how many groups are there? 13, 14, 15, 16, 17 and 18. Total 6 groups, 13 to 18 belongs to P block. ಇವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಇಲ್ಲಿ ಏನು ಬರ್ದಿದ್ದೇನಲ್ಲ, ಇವಕ್ಕೆಲ್ಲ ಏನಂತಾರೆ? P block elements ಅಂತ ಕರೀತಾರೆ. ಯಾಕೆ? ವಿಲ್ ಸಿ. ಹಾಗಾದರೆ we are going to define a P block elements. These are the elements in which differentiating electron or valence electron or ಅದಕ್ಕೇನನ್ಬಹುದು outermost electron, we call it as a last electron. If it enters into P orbital, those all elements were called P block elements. Okay, so you know P orbitals, actually we have px, py and pz orbitals. They can accommodate 6 electrons. Okay, so total P subshell or P orbitals can accommodate 6 electrons. Therefore we have 6 groups. That's a group number 13 to 18, 13 ರಿಂದ 18. ಅಂದ್ರೆ ಟೋಟಲ್ ಆಗಿ ಎಷ್ಟು ಗ್ರೂಪ್? 6 groups belongs to which block? P block of the periodic table. Okay, so can you see 13 to 18, these all elements were P block elements. And here the outermost electronic configuration, Last valence electronic configuration varies from ns2 np1 to ns2 np6 in each group. Okay, we'll see this point how it is. Can you see the screen now? This is the electronic configuration of group number 13. Group number 13 ದಲ್ಲಿ ಯಾವಿದಾವೆ? boron, aluminium, gallium, indium, thallium. Okay, so this group number 13 belongs to P block. No, why P block? We'll see. Electronic configuration, electron ವಿನ್ಯಾಸ, ಬೋರಾನ್ ಧಾತುವಿನ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ವಿನ್ಯಾಸ ಏನಾಗ್ತದೆ? its atomic number is 5, its electronic configuration is 1s2 2s2 2p1. ಶಾರ್ಟ್ ಆಗಿ ಏನಂತ ಬರಿಬೋದು? helium 2s2 2p1. I hope you have studied electronic configuration in your lower class 9th and 10th. You have studied, isn't it? Don't worry, we'll study once again in some other chapter. We have atomic structure chapter. There we will learn once again about electronic configuration. Adre you know already, you know how to write electronic configuration. Boron electronic configuration is 2s2 2p1. Look at the outermost shell. So this is the second shell, is the outermost shell. Ali valence electron ಯಾವ orbital ಗೆ ಹೋಗಿದೆ? This one electron, can you see this cursor now? So one electron present in a p orbital, 2p orbital. Valence electron enters into p orbital. If you take aluminium, 3p1. Valence shell electronic configuration, 3s2 3p1. Last electron enters into p orbital. In gallium, last electron enters into p orbital, 4p1. One electron ಎಲ್ಲಿದೆ? 4p orbital ದಲ್ಲಿದೆ. In indium same thing, thallium same thing, isn't it? ಹಾಗಾದ್ರೆ in group number 13 valence electron enters into which orbital? p orbital. Valence shell electronic configuration 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1. In short, in general, can we write ns2 np1? Isn't it? Okay, this is about group number 13. ಈಗ ಏನು ಹೇಳ್ಬೋದು? group number 13 elements belongs to which block? p block ಅನ್ಬಹುದಾ? ಓಕೆ, ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ p ಆರ್ಬಿಟಲ್ಗೆ ಎಂಟ್ರಿ ಆಗಿದೆ, ಫಿಲ್ ಆಗಿದೆ. ಓಕೆ, come to the group number 14. Next group, carbon, silicon, germanium, tin and lead present in a group number 14. ಇಲ್ಲಿ ನೋಡಿ, electronic configuration of carbon 1s2 2s2 2p2, or we'll write helium 2s2 2p2. So these two are valence electron, enters into 2p orbital. Silicon ದಲ್ಲಿ 3p2, germanium ದಲ್ಲಿ 4p2, tin 5p2, lead 6p2. ಹಾಗಾದ್ರೆ ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಆರ್ಬಿಟಲ್ ದಲ್ಲಿ ಎಂಟ್ರಿ ಆಗಿದೆ? p ಆರ್ಬಿಟಲ್ ದಲ್ಲಿ. ಗ್ರೂಪ್ ನಂಬರ್ 14 ಎಲಿಮೆಂಟ್ಸ್ ಏನು? p ಆರ್ಬಿಟಲ್. ಸೊ ಇಲ್ಲಿ ಜನರಲ್ ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು? ಇನ್ ಕೇಸ್ ಆಫ್ group number 13 it is ns2 np1. here ns2 np2 ಬರಿಬಹುದಾ? ಅದೇ ರೀತಿ if you look at the group number 15, valence shell 2s2 2p3, 3 electrons are outermost electron enters into p orbital. so ಇಲ್ಲಿ 2s2 2p3, 3s2 3p3, 4s2 4p3 ಇದೆ. can we write ns2 np3? okay, so got an idea why 13 14 15 comes under the block p? okay, ಮತ್ತೆ ಯಾವುದು ಉಳಿತೀಗ? okay, before that ಸೊ ಹಾಗಾದರೆ ಗ್ರೂಪ್ ನಂಬರ್ 13 ವ್ಯಾಲೆನ್ಸ್ ಆರ್ಬಿಟಲ್ಸ್ ಏನನ್ಬೋದು? ns2 np1. ನೋಡಿ, 2s2 2p1, 3s2 3p1, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ns2 np1. 14 ಏನನ್ಬೋದು? ns2 np2. In the same way, this 15 2s2 2p3, 3s2 3p3. so general electronic configuration, valence shell electronic configuration is what? ns2 np3. ಈ ರೀತಿ ಬರಿಬಹುದಾ? ಓಕೆ, ವಿಲ್ ಸಿ ಗ್ರೂಪ್ ನಂಬರ್ 16 17 18. so oxygen, sulfur, selenium, tellurium, polonium, this belongs to group number 16. these elements are 17 and these elements are 18. nodi. so in all these elements, if you look at the what electronic configuration, valence electron enters into p orbital. look here, 2p4. 17 ದಲ್ಲಿ ಬಂದರೆ 2p5, 18 ದಲ್ಲಿ ಬಂದರೆ ಎಕ್ಸೆಪ್ಟ್ ಹೀಲಿಯಂ ಒಂದನ್ನು ಬಿಟ್ರಿ. About helium, I'll tell you at the end of today's class. Okay, except helium, look at the neon. 2s2 2p6, last electron enters into 2p. In argon, 3s2 3p6, last electron enters into 3p. Howda? So therefore, group number 13, 14, 15, now here 16, 17, 18. You take any element of these groups, the valence electrons enters into p orbital, hence they comes under the block P. Fine, clear, good. Now, here what's the valence electronic configuration? 2s2 2p3 oxygen, sulfur to, can you see the cursor here? Okay, sulfur 3s2 3p4, selenium 4s2 4p4. In short, we can call it as a ns2 np4. In group number 17, we write ns2 np5. 18 dali ns2 np6. So this ns2 np1, ns2 np2, they are what? General valence shell electronic configuration that varies from ns to np1 to ns to np6 in case of what? P block elements, isn't it? Okay. Nodi, look at this line. The outermost andre valence shell electronic configuration varies from what? ns to np1 to ns to np6 in case of p block elements. Hagadre, what's the general outermost electronic configuration here? Very simple it is. So very important for 1 mark. Enaktiga idu this becomes ns2 np6. Can you see this point? So cursor is not going there. So this is ns2 np 1 to 6. How the ns2 np1 np2 and up to 6. Therefore the valence shell electronic configuration of group P block element is what? This is ns2 np6. Important for 1 mark. Fine. Okay. We'll see some more what features of these P block elements. All the orbitals in the valence shell of the noble gas means last group number 18, are completely filled by electrons. Just we saw that they have ns2 np6. All the p orbitals are completely filled. Therefore, it's a very difficult to change that stable electronic arrangement. Okay, that's called octet arrangement. About these points I'll tell you in the college. Okay, ಇದ್ರ ಬಗ್ಗೆ ಇನ್ನೊಂದ್ಸರಿ ನಾ ಹೇಳ್ತೇನೆ about these points and all. Okay, so they show andre group number 18 elements, they show low chemical reactivity. They are chemically inert. About that we'll see in the college. Okay, preceding the noble gas andre noble gas kinta munche group number 17 ide hauda. These were important groups of non-metals. They were called halogens. Andre p block dali ಏನೇನು ಇದಾವೆ ಅಂತ. We have noble gases, we have halogens, fluorine, chlorine, bromine, iodine, astatine and tennessine. So ಅದಕ್ಕಿಂತ ಮೊದಲು ಏನಿದಾವೆ group number 16, they were called chalcogens. Okay, so about this we'll study later. One point is important, the S block elements and P block elements together ಎರಡನ್ನ ಸೇರಿಸಿ what? S block elements and P block elements are together called as representative elements, or even they were called as what? Main group elements. Okay, so S block elements and P block elements, they are collectively called as what? Representative or main group elements. Important for 1 mark in the examination. Clear? Okay. This is about P block. Next one is D block. In both what are D block elements then? Pretty simple it is. These are the elements in which differentiating electron, valence electron, outermost electron, or even we call it as a last electron, enters into d orbitals, are called d block elements. Since d orbitals can accommodate total of 10 electrons, d subshellದಲ್ಲಿ 5 d orbitals ಇರ್ತವೆ. dx dy sorry dxy dyz dxz dx square minus y square and dz square. Okay, so these points we'll study later. So these what you call 5d orbitals can accommodate maximum of 10 electrons. Therefore we see 10 groups in the periodic table. Group number 3 to 12, 3 ರಿಂದ 12 ಒಟ್ಟೆ ಎಷ್ಟು ಗ್ರೂಪ್ಸ್ ಆಯಿತು? 10 groups belongs to d block elements. Even d block elements are defined like this: the elements in which the d orbitals are being progressively filled ಅಂತಲೂ ಕರೀತಾರೆ. About that we'll study later. Okay, here I'll take an example of a 3D series. Okay, this first series belongs to fourth it's called a 3D series. Actually it belongs to fourth period. Scandium, titanium. So can you see these elements? Okay, 3D series ಅಂತಾರೆ. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. I'll take example of this series. Scandium with atomic number 21, its electronic configuration is 1s2, 2s2, 2p6, 2p6, 3s2, 3p6, 4s2, 3d1. Okay, so ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲಿ. ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಂಟರ್ಸ್ ಇಂಟು 4s, ಆಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಹೋಗ್ತವೆ 3ಡಿಗೆ ಹೋಗ್ತವೆ. ಸೊ ದಿಸ್ ಈಸ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ವಾಟ್? ಇನ್ಕ್ರೀಸ್ ಇನ್ ದ ಎನರ್ಜಿ ಆಫ್ ದ ಆರ್ಬಿಟಲ್ಸ್. ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಂಟರ್ಸ್ ಇಂಟು 4s, ಲೇಟರ್ ಉಳಿದಿದ್ದ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿ ಹೋಗ್ತವೆ? 3ಡಿಗೆ ಹೋಗ್ತದೆ. ಇಲ್ಲಿ ದ ಎಲೆಕ್ಟ್ರಾನ್, ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇಸ್ ದ ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್. ಬಟ್ ವೈಲ್ ರಿಪ್ರೆಸೆಂಟಿಂಗ್, ಬರೆಯುವಾಗ 3D ಮೊದಲು ಬರೀತೇವೆ, 4s ಆಮೇಲೆ ಬರೀತೇವೆ. ಆದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೊದಲು ಹೋಗೋದು 4sಗೆ ಹೋಗ್ತದೆ, ನೆಕ್ಸ್ಟ್ ಉಳಿದಿದ್ದ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಗೆ ಹೋಗ್ತದೆ? 3D. ಹಾಗಾದರೆ ಈಗ ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ದಿಸ್ 3d1 or 4s2? 3d1 is the last electron. Enters into which orbital? D orbital. Hence scandium belongs to D block. Titanium ತಗೊಳ್ರಿ. Its electronic configuration argon, short ಆಗಿ argon 4s2, 3d2. These two electrons are valence electron. Last electron enters into D orbital. Hence titanium belongs to D block. Clear? So in this way you take any elements in these 4 series, ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ತಗೊಂಡು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರೆದ್ರೆ always valence electron move to D orbital only. Hence they were called D block elements. Group number 3 to 12. Okay, so now here valence shell electronic configuration is what? 3d1 4s2, 3d2 4s2, like this. Here d orbitals are being progressively filled. Therefore its general electronic configuration is n-1 d1 to 10 and ns2. For example, in a 3D series, if you consider 4 as a n, ಇಲ್ಲಿ 4ನ n ಅಂತ ತಗೊಂಡ್ರೆ 3 ಏನಾಗ್ತದೆ? n-1, isn't it? ಸೊ ಇಲ್ಲಿ 4ನ n ಅಂತ ತಗೊಂಡ್ರೆ 3 ಏನು? n-1. Therefore its outer electronic configuration is what? This is n-1, n-1 d 1 to 10. d ದಲ್ಲಿ 1 ರಿಂದ 10 ಎಲೆಕ್ಟ್ರಾನ್ ಫಿಲ್ ಆಗ್ತವೆ. and ns 1 to 2. ns s orbital can have either 1 electron or 2 electron. Therefore the general outer electronic configuration of a D block element is n-1 d 1 to 10 and ns 1 to 2. Okay, so about this electronic configuration I'll tell in detail when you come to the college. ಇದ್ರ ಬಗ್ಗೆ ನಾನು ಇನ್ನೊಂದು ಸರಿ ಬರೀತೇನೆ. ಇಲ್ಲಿ ns 1 to 2ನೇ ಯಾಕೆ, ns2 ಯಾಕಲ್ಲ, ಅಬೌಟ್ ದಿಟ್ ಐಲ್ ಟೆಲ್ ಯು ಲೇಟರ್. ಸೊ ಇವತ್ತಿನ ಕ್ಲಾಸಲ್ಲಿ ಏನು ನೆನ್ಪಿಟ್ಕೊಳ್ರಿ, ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಹೆಂಗೆ ಮಾಡಿದ್ದಾರೆ, ಏನೇನಿದೆ ಅದ್ರ ಬಗ್ಗೆ. ಕ್ಲಿಯರ್? ಓಕೆ, ಫೈನ್. And these elements, no, D block elements, they were metallic in nature. These are metals and they form a bridge between what? Chemically active metals. I said no, these are placed between S block element and the P block element. S block elements are more reactive. Okay, these are placed between chemically active metals of S block element, and less active P block elements of group 13 and 14. In a P block element, 13 and 14 are less reactive, whereas 15, 16 onwards they are more reactive. Okay, so ಇವನು ಎಲ್ಲಿಟ್ಟಿದ್ದಾರೆ? ಕೆಮಿಕಲಿ ಆಕ್ಟಿವ್ ಮೆಟಲ್ಸ್ ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಮತ್ತು ಲೆಸ್ ಆಕ್ಟಿವ್ ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಗ್ರೂಪ್ 13 and 14 ಎರಡರ ನಡುವೆ ಇಟ್ಟಿದ್ದಾರೆ. ಸೊ ಹೆನ್ಸ್ ದೇ ವೇರ್ ಕಾಲ್ಡ್ ಎಸ್ ವಾಟ್? Transition elements. D block elements are also called transition element because of this reason, because of their position between chemically active S block element and chemically inactive P block elements of group 13 and 14. They were called transition elements, or even we call it as a transition metals antanu kariteve. Clear? Okay. Now last block, ಯಾವುದು? F block element. These are also called inner transition element. Actually, these belongs to 6th period and 7th period. Transition elements ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಆಗಬೇಕಾಯಿತು. Since their valence electronic configuration is different, they are kept below the main body of the periodic table. They were called inner transition elements, in which differentiating electron enters into which orbital? F orbital here. Can you see two rows are there? This F block element consists of two rows. They were called lanthanoids. These are lanthanoids. These are 14 elements after lanthanum. They are cerium to lutetium. 14 elements were called lanthanoids, and 14 elements from thorium. From thorium to last one Lr, lawrencium. So these were called actinoids. So 14 plus 14, total 28 elements are there. So you know F orbital can accommodate maximum of 14 electron. Therefore, in the first row we have 14 elements. In the second row we have 14 elements. ಹಾಗಾದರೆ F block elements composed of what? They are composed of a two series, lanthanoids and actinoids. Lanthanoid series is cerium to lutetium with atomic number 58 to 71, and actinoids thorium atomic number 92, lawrencium atomic number 103. In all these cases, the last electron added to which orbital? F orbital only. And if you look at the valence shell electronic configuration, it is n-2 F 1 to 14. So F ಅಲ್ಲಿ 1 ರಿಂದ 14 ಫಿಲ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. So it's not important to write the electronic configuration of all these. Okay, so ಇದನ್ನೆಲ್ಲ ಬರೆಯೋದು ಜರೂರತಿಲ್ಲ. ಇದರದ್ದು ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಷ್ಟೇ ನೆನ್ಪಿಟ್ಕೊಟ್ರಿ. ಬಿಕಾಸ್ these F block elements, no, lanthanoids and actinoids, they are least studied compared to S block, P block and D block. ಅದ್ರ ಬಗ್ಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ ಬಹಳ ಕಡಿಮೆ ಇದೆ. Even actinoids are more, they are radioactive. That point will tell you later. Okay, if you remember the valence shell electronic configuration, it's more than enough. It is n-2 F 1 to 14, n-1 D 0 to 1 and ns2. Okay, so about this I'll tell you in detail in the theory classes. So, okay, in the college. And F block elements, they were metals, and we can see similarity in properties within the each series, and they in the elements of a first series we can see similarity in properties, and in the elements of a second series in actinoids also we can see similarity in the properties. And the chemistry of the early actinoids, starting actinoids is more complicated, because since they are more radioactive, and they have been made in a very, very small quantity, nanogram quantities. Okay, early actinoids which are radioactive, they have been obtained in a very, very small quantity, nanogram scale ಅಲ್ಲಿ ಬಹಳ ಕಡಿಮೆ ಇದ್ದಾವೆ. ಅದಕ್ಕೆ even lesser by nanogram quantities by nuclear reactions. Therefore, their chemistry is not fully studied. And the elements after uranium ನಂತರ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಬರ್ತಾವೆ ನೆಪ್ಚೂನಿಯಂ ಅವೆಲ್ಲ ಅಮೇರಿಕಿಯಂ ಕೋಪರ್ನಿಕಿಯಂ ಅವೆಲ್ಲ they were called as what? Trans uranium elements. So this is about the four blocks of the element S, P, D and F. We'll see two exceptional cases about this classification. ಈ ಕ್ಲಾಸಿಫಿಕೇಶನ್ಗೆ ಎರಡು ಎಕ್ಸೆಪ್ಷನಲ್ ಕೇಸ್ ಇದ್ದಾವೆ. ಯಾವ್ಯಾವುದು? ಫಸ್ಟ್ ಒನ್ ಹೀಲಿಯಂ. ಹೀಲಿಯಂ ಬಿಲಾಂಗ್ಸ್ ಟು ಎಸ್ ಬ್ಲಾಕ್ ಬಟ್ ಇಟ್ ಈಸ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಪಿ ಬ್ಲಾಕ್. ಲುಕ್ ಹಿಯರ್, ಹೀಲಿಯಂ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಪಿ ಬ್ಲಾಕ್, ಗ್ರೂಪ್ ನಂಬರ್ 18, ಲಾಸ್ಟ್ ಗ್ರೂಪಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಇಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಈಸ್ 1s2. The valence electrons are 2. Present in which orbital? S orbital. As per our classification, it should have been placed in S block element. But where it is placed? It is placed in a P block element along with the noble gases. Okay. Definition ಪ್ರಕಾರ ಹೋದ್ರೆ S block ಅಲ್ಲಿ ಇಡಬೇಕಾಗಿತ್ತು, ಆದರೆ ಎಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ? P block ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. It's an exceptional case. Why? Because it has a completely filled valence shell. So S orbital can accommodate maximum of 2. It's already completely filled. Valence shell ಏನಾಗಿದೆ? Completely fill ಆಗಿದೆ. In all the noble gases, valence shell is completely filled. P can accommodate maximum of 6. 6 electrons are there. S can accommodate maximum of 2. 2 are there. ಅಂದರೆ 6 plus 2 8 electron. Octet state ಬರ್ತದೆ. Octet state ಏನು? Stable state. In the same way, helium duplet state alide, yes, 1s2. So and the property of helium resembles the property of neon, argon, krypton, xenon and radon. The property of helium element resembles the properties of noble gases. That's why they are placed in group number 18. They are placed in P block elements, since their properties are characteristics of other noble gases. This is one exceptional case. Another one, position of hydrogen is uncertain. ಏನಪ್ಪ ಹಂಗಂದ್ರೆ position of hydrogen is uncertain. This point we will learn in detail in a hydrogen chapter. ಹೈಡ್ರೋಜನ್ ಅಂತ ಒಂದು ಚಾಪ್ಟರ್ ಇದೆ, ಅಲ್ಲಿ ಇದೇ ಪಾಯಿಂಟ್ ಬಗ್ಗೆ ರಿಯಾಕ್ಷನ್ಸ್ ಎಲ್ಲ ಕಲಿತೇವೆ, ಯಾಕೆ ಏನು ಅಂತ. ಹಿಯರ್ ಅನ್ಸರ್ಟನ್ ಅಂದರೆ ಹೈಡ್ರೋಜನ್ನ ಎಲ್ಲಿದೆ? ವೇರ್ ಇಟ್ಸ್ ಪ್ರೆಸೆಂಟ್? ಹೈಡ್ರೋಜನ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಅ ಗ್ರೂಪ್ ನಂಬರ್ 1, ಇಸಂಟ್ ಇಟ್? ಎಸ್ ಬ್ಲಾಕಲ್ಲಿದೆ. ಅದನ್ನ ಎಸ್ ಬ್ಲಾಕಲ್ಲಿ ಇಡಬೇಕು, ಪಿ ಬ್ಲಾಕಲ್ಲಿ ಇಡಬೇಕು, ಪಿ ಬ್ಲಾಕಲ್ಲಿ ಇಡಬೇಕು, ಎಸ್ ಬ್ಲಾಕಲ್ಲಿ ಇಡಬೇಕು ಅನ್ನೋದು ಕನ್ಫ್ಯೂಷನ್ ಇತ್ತು. ಅದಕ್ಕೆ ಏನಂತೇವೆ ನಾವು? ಅನ್ಸರ್ಟನಲ್ಲಿ ಇಡಬೇಕು. ಸಿನ್ಸ್ the properties of hydrogen resembles the properties of halogens of group number 17. In the previous classes I have said you, ಏನು ಹೇಳಿದ್ದೇನೆ? ಒಂದೇ ಗ್ರೂಪಲ್ಲಿರೋ ಎಲಿಮೆಂಟ್ಸ್ದು ಪ್ರಾಪರ್ಟಿ ಒಂದೇ ಥರ ಇರ್ತದೆ, ಹೌದಾ? ಇಲ್ಲಿ ಐ ಯೂಸ್ ಟು ಯೂಸ್ ದ ವರ್ಡ್ ಎಕ್ಸೆಪ್ಟ್ ಹೈಡ್ರೋಜನ್ ಅಂತ ಹೇಳ್ತಿದ್ವಿ, ಹೌದಾ? ಸೊ ಯಾಕೆ ಎಕ್ಸೆಪ್ಟ್ ಹೈಡ್ರೋಜನ್? ಹೈಡ್ರೋಜನ್ ಪ್ರಾಪರ್ಟಿ ಇಸ್ ನಾಟ್ ಸಿಮಿಲರ್ ಟು ಲಿಥಿಯಂ, ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ ಆ್ಯಂಡ್ ರುಬಿಡಿಯಂ. ಇದಕ್ಕೆ ಸಿಮಿಲಾರಿಟಿ ಇಲ್ಲ. Hydrogen property similar to group number 17 of the P block elements. They were halogens. ಅದಕ್ಕೆ ಗ್ರೂಪ್ ನಂಬರ್ 1ದಲ್ಲಿ ಇಡಬೇಕು, 17ದಲ್ಲಿ ಇಡಬೇಕು ಅನ್ನೋ ಕನ್ಫ್ಯೂಷನ್ ಇತ್ತು. ಎಟ್ ಲಾಸ್ಟ್ ಇಟ್ಸ್ ಬೀನ್ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಗ್ರೂಪ್ ನಂಬರ್ 1 ಎಲಿಮೆಂಟ್, ಗ್ರೂಪ್ ನಂಬರ್ 1 ಎಸ್ ಬ್ಲಾಕಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಆಸ್ ಪರ್ ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ 1s1, 1 electron enters into s orbital, ಅದಕ್ಕೆ ಎಸ್ ಬ್ಲಾಕಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಬಟ್ ಪ್ರಾಪರ್ಟಿ ಸಿಮಿಲರ್ ಟು ವಾಟ್? Halogens. Okay, so since it's the first element with 1 electron, it's being placed in group number 1. Clear? So these are two are exceptional case in the classification of elements into 4 blocks. Fine? Yes. ಹಾಗಾದರೆ conclude ಮಾಡೋದಾದರೆ, so we discussed classification of known elements into 4 blocks, S, P, D and F. Isn't it? So what is the basis of classification? ಯಾವ ಆಧಾರದ ಮೇಲೆ ಕ್ಲಾಸಿಫೈ ಮಾಡಿದ್ರು, ಹೇಗೆ ಮಾಡಿದ್ರು, ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದರೆ ಯಾವುದು, ಅದರದ್ದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನು, ವಾಟ್ಸ್ ದೇರ್ ಜನರಲ್ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್, ಆ್ಯಂಡ್ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫೀಚರ್ಸ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್, isn't it, about P block, D and F block. Okay, so even there are some points. For example, S block elements are electropositive. They show positive 1 and positive 2 state. About this, even about P, D and F block. So some other points I will explain in the college, in the offline classes. Clear? Okay. So thank you for watching the video. Please subscribe to my YouTube channel and share the video to your friends. Thank you very much.